Okay, so we talked about the Pythagorean identities. The last set of basic trig identities are what I am calling the symmetric identities because they're all based on how the trig functions are symmetric or describe things that are symmetric in the unit circle. So let's take a look. So here's the idea. Let's say I want to know what is cosine opposite theta equal to. Is cosine opposite theta equal to cosine theta? Is it equal to this? Is it equal to this? Is it equal to any of those? There's two different ways you could think about it. You could think about what these are literally describing on the unit circle, or you could think about the graphs of these functions and transformations of the graphs. So let's do both because they're both helpful. So let's say I have a positive angle theta. Let's start here. What would just cosine theta be? We talked about this last video. Cosine theta, because this is the unit circle, hypotenuse is 1. So using the SOHCAHTOA definition of cosine, we'd say that cosine theta is the adjacent side over the hypotenuse. But because the hypotenuse is 1, it's really just equal to the adjacent side length, which is the same as the x-coordinate of the point there. All right, so that's what cosine theta is describing. What does cosine opposite theta describe? Well, the first thing you have to do is think about what's this opposite theta mean. If theta is a positive angle, that means we are wrapping in this direction. If we are taking the opposite of that, that means that we're going the same angle, but we're wrapping in the other direction. So we're going clockwise this way instead of counterclockwise that way. So this would be now an angle of negative theta. But you'll notice that because it's the same angle, you end up with points that are perfectly symmetric around the x-axis here. So this would be the point x minus y. And you can see that if you're going to take the cosine of this angle, it's going to tell you the same horizontal distance. So just by thinking about what these things are describing about the unit circle, we know that those two must be equal to each other. What about this one? Think about what would this one be describing. Here I'm saying first take cosine theta, which is this x-coordinate, and then take the opposite. So this x-coordinate in the picture I've drawn would be a positive number because it's going up this positive side of the x-axis. If you were going to take the opposite, that would be the negative x value. So it would be over here. So clearly that one's not correct. What about pi minus theta? Well, remember, pi is the angle that's equal to 180 degrees, so pi radians. So what would an angle of pi minus theta be? Well, this is like 0 plus theta. Here's pi. Pi minus theta would be here. Because I'm at an angle of pi and I'm subtracting an angle of theta, so I'm wrapping it around that direction. So you see this should have the coordinates negative x, y. If I'm finding the cosine of that, it's telling me what is the x-coordinate over here. So clearly this is a negative x-coordinate, that's a positive x-coordinate, so these two can't be the same. However, this one is true, because I'm finding the cosine of this angle, which is taking me to that point. That cosine is going to be a negative number, but now I'm taking the opposite of that negative number, which is giving me a number of the same magnitude, but the positive version. And so clearly, this distance is the same as that distance, and so those two should be equal. So that's sort of the first set of examples. You can think about what do they describe on the unit circle and kind of work out which ones are equal to which ones. You can see this same fact by considering the plot of y equals cosine theta, and then thinking, what types of transformations are each of these describing here? So what would cosine opposite theta be? Well, here I am taking the opposite of this input value, and so you know that's the same thing as a horizontal reflection around the y-axis. So if I want to know, are these two things equal, that's like me asking, is the graph of cosine theta the same as the graph of cosine theta when I reflect it around the y-axis? So like when I apply that transformation, do I really get the same graph? And clearly, sort of visually, the answer is yes. I can reflect it here. This point maps there, this point maps there, and it's going to be the same. So you can either think about what they're literally describing about the unit circle, or you can think about what transformation is this describing about cosine, and does the transformation actually give you the same graph in the end, which would mean that it's not actually changing your function at all. Okay, so in the problem set, you're gonna, identify what some more of these are using this kind of thinking.